Hi, welcome to Horizontal Autoscaling with Kubernetes. This is going to be a lot of fun. I really enjoy this part. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. Have you heard that yet today? Has it worked? Did you get the slides? You didn't? Yeah, me neither. Which is why you can go to robrich.org. Let's head there, robrich.org. We'll click on presentations. And here are the slides that we are going to see there online right now. Achievement unlocked! Woohoo! So while we're here on robrich.org, let's head over to the About Me page. Thanks for the introduction. I'm a developer advocate for Shoreline. Both Microsoft and Docker have given me some awards. And I'm also a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday afternoon. We complete that software and deliver it back to the charities on Sunday afternoon. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Pasadena or wherever you traveled from, find me here at the event. Hit me up on Mastodon or Twitter or email. And let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, the tip of the captain's hat award from Docker, that was really fun. I've written a few books, I run a few user groups, I've worked on a few open source projects, but one of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode, they read my comment on the air, and they sent me a mug, woohoo! So there's my claim to fame. So let's talk about horizontal autoscaling in Kubernetes. We talked about this guy. So I'm going to do this. I'm going to say kubectl get pods. And I see that I only have one app to scale. I'm going to come in here to this API, and I'm going to say, I would like 4, please. And it's going to say, OK, you can have 4. So I'll come back in here, and I'll give it a second to go find it. And now I have 4. And I'm like, well, actually now I would like 0. And give it a second to find that new metric, and now I have none. And so that is manually scaling Kubernetes. We can see that we can get more and less pods, and let's figure out how to do that automatically. So yeah, that was fun scaling. Let's take a step back. We kind of started in the middle, and take a look at what is scaling. Well, first off, why do we scale? Well, we scale because when we need extra capacity, we want to be able to do more. And when we need less capacity, we want to pay less. So cloud-based utility billing has made this possible, and we can now scale, which is really cool. As we scale, we could look at horizontal scaling or vertical scaling. Vertical scaling is to get one bigger machine. Horizontal scaling is to get more littler machines. And we could definitely scale either way. Well, when might we scale vertically? Well, we probably have a monolithic system that needs to keep track of everything. And so we'll scale vertically to get a bigger machine if we need more capacity in something that can't, say, multi-thread. So, for example, a database. Maybe we have a legacy database, a SQL database, that has to keep track of primary keys and automatically increment them, and so we can't horizontally scale that. By comparison with horizontal scaling, this is great for parallelizing workloads. If we have lots of little machines, we don't need to, say, keep buying a bigger machine. We may run out of bigness. And so we can get lots of little machines. We can spin them up. We can spin them down. So it's really great for stateless things like web servers. So how did we get here? How did we get to the point where we can automatically scale? Well, in the olden days, scaling was slow. So I need to have enough capacity, so I need to buy that many machines, because I can't exactly say, buy a new machine within the 2 seconds that the request comes in before it times out. So I need to have pre-bought that machine. And then I'm planning for my peak capacity, and so now that I've got peak capacity, well, that means that on all the rest of the days, my machine is mostly idle. 5% CPU, 10%? Why did I buy all this hardware if it's just going to sit there? Well, then on that one day, maybe it's Black Friday or Super Bowl Sunday, when our site went viral, then we had lots of traffic, and now it's like, well, that's why we bought it. But still, it stays idle most of the time. Well, yeah, here's that process. I went through this with one of my employers where we had to go through the tribunal, we had to get the hardware purchased, we then racked it, we plugged in all of the pieces, we installed the operating system, we installed the application, we added the machine to the load balancer. All of that process took weeks or months. This is not something that we can do when we got slashdotted yesterday. Today, we have utility billing. Clouds give us the ability to be able to spin up and spin down things really quickly. We can just turn things on. When we're done, we can just turn them off. So we don't need to over-provision anymore. We can provision for the scenario right now. And if right now changes, we can buy more or less. So the cloud has really empowered this process of being able to scale, which is amazing. If we need more capacity, we can scale up. If we want to pay less, we can scale down. So the cool part about that is that's scaling kind of in general across all topics. And now let's kind of apply that more towards Kubernetes. Well, when we get here into Kubernetes, we could talk about scaling the cluster or scaling the workload. Now, scaling the cluster is definitely important. As you grab these slides from robrich.org, click on each of the blue links to learn more. That's not what we're going to do today. Scaling the cluster is important, but we're going to presume that that's done. We're going to instead focus on scaling the number of pods. If we need more capacity for this website, we need more pods. If we need less capacity for the website, we need less pods. Now, we could definitely go horizontal or vertical here. We could get bigger pods by setting the resource limits, and at that point, then we have the same number of pods, we just have bigger ones. That's vertical scaling, and we could definitely pursue that. Grab the slides from robrich.org and click through here to learn about it. Or we could look at horizontal scaling, which is where we'll dive into. How do I add and remove the quantity of pods based on the capacity that I need? So we're going to talk about horizontal pod scaling today. The other topics are really interesting, and later over beers, let's definitely dig into those. Today, let's horizontally scale our workloads. So the first question we usually hit is, well, why isn't this automatic? Can't I just push the Scale Kubernetes button? Well, it depends a lot on your workload. Uh-oh, it depends. Quit telling me it depends. It depends on what? It depends on this. What is the right metric for your workload? What is the critical piece that defines if your workload is over capacity or under capacity? Is it CPU, memory, concurrent requests, the request queue length, the number of messages in your service bus, latency in a critical function? What is the metric that is critical to your system? If we choose the wrong metric, we could artificially scale too high in a scenario that doesn't matter, or artificially keep it too low, leading to system outages. We need to pick the right metric to scale on. And this is why it isn't automatic, because it depends on what is the metric in our workload. So picking the wrong metric. Let's scale based on CPU, because if our application is using more CPU, then it makes sense that we ought to scale up. But in this case, our application is not a CPU-bound workload, it's an I/O-bound workload. We're going to spend the majority of the time waiting on external services. And so because the CPU never gets any higher, yes, we got slashdotted, we went viral, we have lots more capacity, and we're staying really low. We didn't automatically scale. Because the metric that we chose was CPU, and CPU wasn't moving. We didn't choose the right metric here. Let's look at another scenario. In this case, we're going to scale based on the number of concurrent requests. Now, we've got our I/O-bound workloads, so I think we're doing okay right now. That's great. But our framework will automatically cap the number of concurrent requests to ensure that each request processes faster. And instead, it will apply back pressure on the incoming queue. So we'll have a request queue length that gets bigger, but the number of concurrent requests did not change. So again, we're going to keep our scaling artificially low We're going to have now maybe system outages because, well, we're not getting the capacity that we need because we didn't scale up. We never had more concurrent requests than what was running in our system. Oops, we picked the wrong metric. Let's take a look at a third scenario, and in this case, we're going to do it correctly. So we could scale based on the service bus queue length. Now, in this case, our application is going to send some emails, and so when we fill up the queue, then we know that we have lots of messages. We're going to scale up to lots of instances of our application. Each one's going to pick a message off and send that email, and then once the queue is empty, then we'll scale back down. We've sent all the messages. So in this case, we were able to scale correctly because we were looking at that critical metric in our application that made our application more performant by scaling up or down. So it depends. And it depends on what is important in your application. Now, your application may be very different than mine, and so you may choose to scale based on different criteria than I do. Because in your application, perhaps it is CPU bound, or memory bound, or bound to the number of concurrent requests, or the queue length inside of a service bus, or something completely different. So now that we've identified that we need to choose the right metric, how do we now apply that to Kubernetes? Well, we have the Kubernetes Autoscaler. And the Kubernetes Autoscaler is great for the built-in metrics. So let's first start with how we might install and configure the Kubernetes Autoscaler. So we first need to install the metric server. Now the metric server is going to collect CPU and memory from all the pods, and that it can present those metrics then to the horizontal pod autoscaler so that the horizontal pod autoscaler can make choices about how many pods need to be run. So first up, let's see if the metric server is on. So let's grab this. We're going to look at the top pods. So we'll look at the metrics. Here's all the pods across all of our namespaces. Here's how many CPUs and memory each one is using. We've got our metric server installed. Excellent. Well, if we didn't have our metric server installed, easy enough. We head off to the metric server repo in GitHub. We go apply components.yaml from the latest release, and up pops the metric server. Then we can come back here and we can go check to see if we have a top pod, if it'll show us the memory and CPU. In this case, it does. So we've got the metric server running. Excellent. Next, we deploy our workload. Now, this can be a deployment set, a stateful set, a daemon set, whatever you want to deploy. These are the things that we want to scale. And it's important that we set the resource limits here, because what we're going to do when we scale is say, of all the pods, how are they doing in this resource limit? Have they hit the resource limit, in which case we need more pods? Or are they mostly idle in that particular measurement, in which case we need less pods? So if we're not setting our resource limits, Kubernetes doesn't know what too much means, and will probably just leave us alone. And then the big thing, we need to remove the replica count. If we deploy a deployment and we specify the number of replicas, then the horizontal autoscaler will come back through and fix it, but for a time, it will reset every time we go back and redeploy that deployment. Because, well, our deployment says you ought to have 2 replicas. Maybe our horizontal autoscaler scaled up to 8 or 30. We deploy the next version, it goes back to 2. Leave the replica count blank and let the horizontal autoscaler populate that process. Okay, so here's a deployment, or maybe it's a stateful set or daemon set, and here's that replicas, and I very specifically commented it out, and I gave a reason for that, because somebody's going to come by and see this and go, oh, they forgot to specify the replica count. Let me add that. And, well, next time you deploy it, it's going to scale back down to 2 or 1 or 3, and it's like, but the horizontal autoscaler, leave replica count out. Cool. So now that we've got our metrics server, we've got our workload, we're measuring the capacity of our system, next we'll add a horizontal autoscaler. And this is the built-in piece inside of Kubernetes that will go measure that metric and know if it needs to make decisions. So it's going to take a look at the pod counts and the resource limits and try and get it as close to that resource limit as it can without going over. And if it goes over, it'll add some. So it will check by default every 15 seconds. And once it makes an adjustment, it will leave it be for 5 minutes. If we were to say scale up and then immediately we reach capacity and now we scale right back down, it'll kind of keep sloshing or flapping up and down. If it takes a while for our application to spin up, maybe it's scaled up, but it takes a while for it to boot and populate its cache and do the things. And so, well, then it's going to notice that the capacity hasn't changed and it'll scale up again. So by default, it will check every 15 seconds and it will leave it that way for 5 minutes. So how might we apply a Kubernetes autoscaler? Well, we could just say kubectl autoscale. We'll specify the thing that we want to scale. In this case, it's a deployment. We'll give it the name of the deployment, and we'll give it the limits that we want to check. In this case, CPU percent. I want CPU percent to be 50% of that limit. That's probably a little low. 80 or 90 is probably better in this case. We'll also give it a min and max. Now that's interesting, but we kind of want YAML, and so, well, here's the YAML, the horizontal pod autoscaler. Now, this is a bit more verbose. That's where, maybe the command line gets us close, and then we can pull that YAML back out and trim it to this spot. But yeah, here's the full YAML. So we've got the min replicas, the max replicas. We've specified what we want to scale, and we've specified how we want to scale that. In this case, I want the CPU to be at 50% of the limit. Cool. So now we'll apply our horizontal autoscaler, and it will be able to take actions on those direct metrics. So I've got here a deployment, and this is going to just run this node example app, which is just a really simple app that responds to requests in hello world. I've set some limits. I want it to take at most half a CPU. Yeah, I could specify other limits, but we'll come back to why that may not be a great idea. But that's why I've got this squiggle here in VS Code. It's like, hey, you didn't specify the other limits. Yeah, I know. I've also got a service wrapping this just so that we can get at it. So let's do that. Kubectl apply -f CPU deployment. Excellent. Let's actually grab the horizontal pod autoscaler as well and then look through it. Here is the horizontal pod autoscaler, and we saw that before where we have a min replicas, the max replicas, what we want to scale, in this case a deployment. Here's our deployment. What do we want to look for? Well, we want to measure based on CPU, and in this case, because a node app is pretty efficient, I'm going to set this incredibly low so that hopefully we can see it. And then I'm going to set the stabilization window seconds to 1, just so that it won't wait the whole 5 minutes. We want to be able to see our demo move up and down faster. But yeah, this is going to flap a whole lot faster. In production, that's a really bad idea. Okay, so kubectl get all. And let's take a look. We've got our horizontal pod autoscaler. Now, it's going to check every 15 seconds, and so it hasn't found that metric yet. But we see that we have our node example, and it's running, and we have, this is the hardest part of this demo, waiting the 15 seconds for it to find the metric. The cool part is that you can set the timer up and down a little bit, but it's by default only 10 seconds. So, or the lowest it can go is 10 seconds. So yeah, I have to waste 10 seconds here. Cool. So right now we're using 0%. So if we do a kubectl top pods, there's our node example. Right now it's using 0 memory or 0 CPUs. And so let's add some load. And so I'm going to come in here and I'm going to go grab a thing here and let's add some load. Now here I'm just going to spin up BusyBox. I'm going to say while sleep, go query that server, and so, Node is quite memory efficient, so sometimes this demo doesn't work at all. But yeah, let's go blast it with some load here. Now that we've got some load running, and in this case, we'll actually even say, let's add a little bit more load. I'm going to get load generator 2. Now that we've got some load coming in, let's take a look at our pods. And we're still measuring every few seconds, every 10 seconds. So now it's using 0.7 of a pod. So now we've got to 2%, and it is so efficient, it's hard to get it to spike. 2%. What I find actually really hilarious in this case, because it is so efficient, sometimes stopping load kicks it over, and so it's like, oh, okay, now I'll do it. So let's stop some load. Now we need to wait 10 seconds for it to figure it out. We're still at 2%. And this demo is going to fail. Oh, we went to 24%. Now because we're not quite 5 times the load of our 5% goal, we're going to spin up a whole lot of new pods. Here's 4 pods. Now we've specified that we want to jump in groups of 4. So there's our 4 pods. We've got some containers creating. And in 10 seconds, it'll notice that it's good, and it will probably come back down. But there, we just auto-scaled based on CPU. We got our CPU to spike. We got more pods. When our CPU is done, then we'll get less pods. kubectl delete. Let's delete our deployment. Let's delete our horizontal pod autoscaler. Cool. So in this demo, we did it by CPU. And both CPU and memory are built in because Kubernetes is measuring those anyway, which is really cool. So what if we want to look at other metrics? Well, our next stop is the mental model that we had. This was kind of where we were looking at, where we have our app, and every 15 seconds, our horizontal pod autoscaler is going to query our app and then calculate what it needs to do and then scale it. Well, yeah, that's kind of what we did, but remember the metrics server? It's kind of this instead. I wish I could take credit for these graphics, but they came from this website, and it's amazing. So it actually queries the metrics server, and so, well, the metrics server is actually a metrics API that has 3 pieces. So the first piece is the internal metrics, where it measures CPU and memory, but we could also plug in custom metrics, and we could plug in external metrics. Custom metrics where we're looking at other pieces within our pods, and external metrics where we're looking at things external to our workload. Perhaps we're looking at queue length, or number of incoming requests, or time of day. So now that we've got 3 pieces, well, our first piece, the built-in things, we have CPU and memory. As we look to custom internal metrics, we might look to Prometheus or other things. And as we look to external metrics, we might look to queue length, we might look to the service bus message count, we might look to external workloads in an app. We could measure anything. Maybe we're looking at latency within the database or number of records in a particular table. Okay, so we want to then plug in different pieces. Now, if we're doing internal things, we've got the metrics server looking at cAdvisor that just looks at our pods. That's great. If we're looking at this, let's take a look at the Prometheus adapter. Now, this Prometheus adapter is free and open source, provided by the Prometheus project. So we'll install Prometheus, and then we can measure whatever Prometheus metrics we want to look at. So let's take a look at that, the Prometheus metrics. So our first step is to install the metrics server. We saw how we did that previously. Excellent. Now that we've got the metrics server installed, let's install Prometheus. Now there's a couple of ways to do this, but in this case I chose to grab the Helm chart from the Prometheus community GitHub. So I'm just going to install the Helm chart, and now I've got Prometheus running in my system. Next, I'm going to install that Prometheus adapter, the one that connects Prometheus to the metric server, so the metric server knows how to query into Prometheus to be able to get specific metrics. So if I haven't already, I'll add the Prometheus community Helm repo. I've got that in place. And then I'll install the Prometheus adapter from that particular Helm chart. But I also need to tell it that Helm isn't running on 7,000 something. It's actually running on port 80. Yeah, I probably could have configured Prometheus to run on port 7,000 something like it usually does, instead of just taking the default from this Helm repo. I kind of liked configuring it this way. But ultimately now I've connected the Prometheus adapter to Prometheus, and then we can now in our workload give it annotations. Now this is really cool. So I'm here in my deployment, and in my deployment, I'm just going to give it some annotations that says, yes, I would like you to go grab Prometheus metrics, and here's the path to the metrics, and here's the port. So just go query that port, go grab that metric, and now we've got our metrics pulled in. That's excellent. And now anything that Prometheus is harvesting, we can now scale based on that. So perhaps Prometheus is measuring not only the memory and CPU, but it's maybe measuring the requests per second, or measuring other metrics about our application, database latency time, amount of resources cached, queue length within a particular function, and we can now scale on anything that Prometheus can measure, which is excellent. So now we'll deploy our workload. We have those annotations here inside our deployment, so we don't need to build anything wacky here. And then we've got our horizontal pod autoscaler. Now, our horizontal pod autoscaler previously was configured to measure CPU. In this case, we're going to tell it to measure a particular Prometheus metric. So we're still doing our min and our max replicas. In our deployment, we're still leaving off the replica count and using this min and max replicas instead. We've got our deployment that we want to scale, and then we're giving it the metric name from Prometheus. And we want to tell it what value is good. So when Prometheus starts to report a value higher than this, it will scale up by that many pods. If our Prometheus value is less than this, then it'll start to scale down if it can. We could also specify other things like stabilization window or scaling frequency here too. Cool. So that got us the Prometheus metrics. Now we're able to scale not just on memory and CPU, but on anything that Prometheus is able to harvest out of our application. Cool. So next up, let's take a look at scaling by something else. Now what might we measure? Well, maybe we want to measure the number of incoming requests, or the queue length inside of our service bus, or the number of records inside of Redis, or the latency that we have on a particular function, and then scale based on that. So we can look to other projects, and I like this project. This project is an open source GitHub repository that is able to pull in lots of different metrics from lots of places. So the cool part is that you can do a JSON API, you can pull off Prometheus metrics, although arguably the Prometheus adapter is a little better for this. InfluxDB would be a great example for how to query any database. Maybe you might want to query from MySQL or Postgres or Redis and be able to pull in metrics that way. An AWS collector that is really elegant at being able to harvest SQS queue length. That might be a great example that you might choose to extend to query Azure Blob Storage or another queue. Zmon collector, and one that I find particularly interesting, scaling on a schedule. If this is a dev or test server, and we only work from Monday to Friday, 9 to 5, do we need to run it overnight or on the weekends? Now that's kind of weird because we want to auto-scale based on load, and this is a schedule. But maybe that's perfect. If we're only running from Monday to Friday, 9 to 5, we're only running a third of the time. In theory, our cloud bill now ought to go down by 2/3 just because we're not consuming those resources except for during business hours. That's really brilliant. We could also scale based on Istio events. There's an Istio metrics adapter in the same way that we had a Prometheus metrics adapter. Grab these slides from robrich.org, click through the blue link, and that's going to be a lot of fun. I'm going to skip that one for the sake of time because Cada is amazing, and this Cada demo is really cool. So Cada is an open source project that allows us to be able to horizontally auto-scale based on a whole lot of other things. Now, I like to walk that chain specifically because if we're only scaling based on CPU and memory, then it's built in, more or less, and we can just grab that. If we have Prometheus metrics, the Prometheus adapter is going to be great because we're probably harvesting Prometheus details and we don't need a lot of additional weight. But if we want to scale on something else, Cada is a good first stop to look at because they have a whole lot of adapters. Redis, Kafka, RabbitMQ, AWS SQS, Azure Event Hubs, a SQL query to MySQL to Postgres to MS SQL, also queries to MongoDB and InfluxDB, Query Elastic, Prometheus, and I'll pop open this page because it's just amazing. Go. I'm clicking just above the link. There it is. The scalars that they have available. So, you know, here they are right here. There's a few. And the one that we're going to explore today is the metrics API. Metrics API. There we go. And so we can specify the metrics API. We're just going to call into this API, expect some JSON. Here's the path in that JSON to adjust, and here's our target value. So let's go poke at that. Cada scaling. So we first need to get Cada installed. There's a Helm chart for that, which is really great. And so, not that one. Okay, I went off the rails and I got lost. The Helm installer. Oh, it's not going to do it. Okay, let's go this way. Nope. Deploying with Helm. There we go. So we'll add the Cada core repo. We will Helm install Cada core. And so I've here got Cada installed, excellent. It did take me a bit to pull the Cada containers, but once I had that in place, it was great. Okay, now that I've got Cada installed, we're going to scale based on the metrics, hitting an API. So I have here this cute little app that is particularly dumb. Now we could definitely query anything, but in this case I'm querying that value right there. And this value, I can choose to get it by just calling it a get, and I'll just return that value. Or I can choose to set it so that, you know, if I have a value and it happens to be a number, then it will set that value, and then other things can get it. Cool. So I've got this API that I can now say, well, let's go get the current value. I'm going to go get the current value, and it's right now 0. Well, I want to set it to 1, so I'm going to set it to 1, and now its value is 1. We could, you know, adjust it maybe based on business logic within our organization or time of day, a cron schedule. We could query anything to be able to calculate this value. But I chose to calculate it based on something dumb, based on this number here. But we wrap that up then into this node app, and we're going to deploy that node app as the metric API. Now, yeah, I definitely need more than one replica here in case, you know, high availability on this particular app, but I'm just going to expose this. I'll expose it on a node port just so that we can play with it here. But I now have this metric API that we can play with. Cool. So kubectl get all. I've got the metric API started. I've got the metric API deployment started, so I have one particular pod. That's the one that's keeping the value. I only wanted one in this case because, you know, it's a variable in my code. Yeah, I probably should push it to a data store like Redis or something like that. Cool. Now that we've got our metric API, then let's have our app that we want to scale. Now in this case, I went really simple. I just want to scale Nginx. So I'll just go grab the Nginx container and I'll push that into place. Notice how I commented out the number of replicas. I want the horizontal pod autoscaler built into Cada to do this. I don't want subsequent deployments to keep resetting it. If I put it here, it would come back down until the horizontal autoscaler noticed and pushed it back up. Okay, so we've got this app. We've got resource limits, but those aren't what we're using to scale, so that's probably fine. We've got a service in front of it. Let's deploy that. We've got now our app to scale service. We've got our app to scale deployment. And so we could come in here to this particular URL. We'll come to localhost. And we get Nginx. Cool. Now Nginx is probably really memory efficient. We didn't need to build it. That's cool. Then let's put in the cada piece. Now if you're using cada v1, then you use this namespace. If you're using cada v2, you use this namespace. If you've got the Helm charts pulled in, you're actually using cada v2, which is really cool. And why are they both v1 alpha 1? I spent a really long time trying to Google, but I want v2. Because I'm like, but it's v1. Yeah, thanks. Naming is hard. Okay, so what am I going to scale? Well, I want to scale a deployment, so I'm giving it the API version and kind of that particular thing. I want to scale my app to scale. Now Cada knows what it needs to do. I'm going to give it a min replica count and a max replica count. I'll go from 0 to 10. That works out pretty well. I'm going to give it some really insanely low metrics of how often to look. So it will poll every 5 seconds. It'll cool down for 1 second. So, it'll only give it a second before it goes and tries to check again. And the stabilization window is off, so we won't now have to worry about it. We'll be able to scale up and down really fast. So I want to scale based on the metrics API. My target value is 1. So if my API returns 1, I should have 1 pod. If it returns 2, I should have 2 pods. And here's my URL to my metric API. And I do need to include the namespace here. I can't just include the URL because it needs to be able to resolve it through any namespace in my Kubernetes cluster. And then what's the path that I need to get to that particular thing? In this case, I'm just returning value. Cool. So let's apply the horizontal pod autoscaler. And now we've got our horizontal pod autoscaler. And it's going to keep trying to measure this. So let's set this not from 1. Let's set it to 6. And kubectl get HPA. We can now see that it should have 6 things. So kubectl get pods, and we see that we have 6. Now, they're still spinning up. They haven't spun up yet. We kind of raced it to the goal. But that was cool. We had this API that we measured something, and we got it up there. So let's go from 6 to 10, and then we'll go check our pods. Now we've got 10. That's excellent. Let's go from 10 to 1,000, 10,000, because I think that's a really good idea. Let's do 10,000 pods. And it says, hey, wait a minute. I've got a max of 10. I'm only going to scale to 10. So we still have 10. Perfect. So I think 10 is too many. I'm going to come back down to 3. And so let's come play with this. And now we've got to 3M, 3 thousandths. So let's get the pods. Now we've only got 3. And let's come back down to 1. And now let's wait for it to measure. It's got 1. Let's get the pods. Now we only have 1 running. And here's a super awesome magic trick. I would like 0, please. And now we have 0. Cool. Now we chose to do this based on calling an API, but we could also do this based on calling ActiveMQ, Kafka, Pulsar, CloudWatch, DynamoDB, Kinesis, SQS, Application Insights, Blob Storage, Data Explorer, Event Hubs, Log Analytics, Monitor, Pipeline, Service Bus, Storage Queues, Cassandra, Couchbase, CPU, cron, Datadog, Elasticsearch. There's a few different things that we could query to be able to do these metrics. We chose to hit an API because now we can do custom business logic based on whatever our application needs, but we could definitely query out into anything. Cool, that was cada. Any questions on cada or the other autoscalers that we saw so far? Yep. Good question. So we just went to minimum pods of 0, and minimum pods should be 1. In most scalars, 1 is the minimum because, you know, if we get to 0, our site is offline. That's probably not a really good idea. So yeah, we probably ought to come back in here into our horizontal pod autoscaler and say our minimum is 1, not 0. Unless we really, really do want it all the way offline, but we'll come back to that. Yeah. Good call. 0 is definitely a magic trick. Any other questions right here?
Yeah, hang on. I have a microphone for you, so everybody
Sorry,
can hear your
we
question.
interrupted her knitting.
Yeah, on your Node Express, I mean, what was the metric that we were measuring to scale it out?
Good question. What was the metric that we were measuring? We said go hit this API, which just happens to be this Node app right here. Yeah, go hit this API, so basically go run this thing, hit this particular endpoint, go get this value, and because we want the value piece out of it, then this is going to be the number that is that metric. Now in my case, I went super simple and I said, the ideal for one pod is 1. Therefore, if I hand you 2, you ought to have 2 pods. But this could be 1.7, this could be 10,000. I could, you know, pick that metric however I wanted to be able to scale based on the needs of whatever metric value is coming out of that service.
I think I saw a question here.
Is this an internal counter? In this case, yes. Cada, the cool part is it can query anything. So I might choose things within my cluster, I might choose things external to my cluster, I might choose something, say, like number of incoming requests.
Can you scale Azure functions using cada?
Can I scale Azure functions using cada? The cool part is that there is this really cool FAQ right here on the cada blog. And one of the things that it says is, does cada only work with Azure functions? Nope. Should we use cada if we're already using Azure functions? Nope. Azure functions does its own thing, and so yeah, if you're just using Azure functions, you probably just want to use Azure functions scaling mechanisms instead of cada. Great question.
How do you debug when your scaling hasn't worked? Like, is there traces? Is there any other way to catch?
Good question. So how do I debug when my scaling doesn't work? Well, I actually built a cool thing here as I was futzing with it that I set here in outtakes. I'm going to pull it up. I wasn't sure if I was getting the metrics out of my system, so I built this really stupid container that went and queried my metrics too. If you're pulling these metrics out of Prometheus, then you've also got Grafana that is visualizing these metrics. If you're pulling these metrics from Application Insights or CloudWatch, then you can watch them there. But you know, ultimately it's like, well, now is the problem that the metric didn't show up, or is it the problem the horizontal autoscaler isn't configured to read it right? You know, once you can split that in half, then debugging it becomes much easier. The other thing that's really cool is that I came in here, kubectl get all and scaled object. I can take a look at this scaled object, kubectl describe that, and it will tell me about, hey, I did this and I did that. If I'm not using cada, if I'm just using a regular autoscaler, then let's describe our autoscaler. And this is ultimately how I was able to find my bug. It said, I'm trying to read it and I can't find the host. And I'm like, why can't you find the host? I'm querying, you're going to laugh at me because this is hilarious. I'm querying the metrics API. So I had it set to the metrics API. And my metrics API was the metric API, not the metrics API. And so, yeah, once I was able to get that detail, then I fixed my bug, and then I was able to pull my values. Great question.
Kind of related, is there any like fallback mechanism if your horizontal, metric isn't available? Can you fall back to something else?
Oh, good call. What happens if the metric isn't available? Well, the horizontal pod autoscaler wants to give you the best chance. So if it's going to scale down and the metric isn't available, it's going to presume it's at 100%, and therefore it won't scale down. If it's trying to scale up and the metric isn't available, it's going to assume it's at 0% and then it won't scale up. And so if that metric is available, it won't do anything. It'll just wait and try again next time. But yeah, ultimately, you want your metric to be highly available. In case it's not, it's like, but yeah, it needs to be.
So hey, Rob, I thought I saw something that when you have like two good pods and you were autoscaling that, it seemed like it terminated them and created two different pods. Was I seeing something?
Yeah, when I was playing with it, we were getting some new pods, and then when we scaled down, it was like, but they were still creating. Yeah, I was scaling fast enough that they hadn't had time to create yet before I killed them off. So they still weren't done spinning up. I've also got my Minikube cluster set really small, so it just didn't have capacity enough to launch them all. But I hand-waved over that really nicely, huh?
Okay. So on a related note, is there any way to granularly to spin up pods, like say that you had a min and max from 1 to 10 and you wanted to do it in step iterations of 2 or 3? Is there any way to do that?
Yeah, one of the things that I didn't configure here that is really cool is I can specify limits around step length. Do I want to step up in more, oh, there it is. How many do I want to jump at a time? And so in this case, where is the step? Cooldown period. I'm looking right past it, I'm sure. It's a default of 5. And so I was like, yeah, that's pretty good. It'll only do 5 at a time. So yeah, if I'm scaling from 1 to 1,000, it may take me a minute. So I probably want to set that a little bit larger.
So we might have time for one more question.
Yeah, and I've got some more stuff, so let's do other
Okay.
things. We looked at how we might measure each of these 3 things, which is cool. We did it in different ways. Some best practices, make sure that you don't put in the replica count in your piece, because as you apply the new version, then you're going to reset back to that version, and then the horizontal autoscaler will have to come back. You probably don't want to leave off the max because it's easy to scale up too high. Now there's lots of places where that could happen. A DDoS attack, a hack attempt, a bug in your code, and you may end up paying for the hack. So setting a max is really important. As you set that max, then you won't scale up any higher than that. Scaling too low. 1 is okay, but 1 may lead you to hardware failure. So to be highly available, you probably want to set your min to 3. We talked about missing metrics. There's the piece right there. It resets to 1 on deployment. That's because I left the min replica or the replica count in my deployment, and because I did, as it deployed, it reset. Flapping or sloshing, where it scales up, and then it notices it has too many and scales down, and then it notices it has too few. A good way to do that is to set the stabilization window, and then you'll solve that one. So how do I scale to 0? I'll always have something running, but the hard part about scale to 0 is, well, what happens when that request comes in? What wakes it back up? That's where cada is really amazing. Cada is one, Knative does a similar thing, but cada is just amazing at being able to say, okay, I'm going to target based on number of incoming requests, and when there aren't any, I'm going to turn the service off. Now you pay nothing. Well, you pay for the cada containers. But it's going to reverse proxy in front of your service so that it can catch that request and spin up the pod to be able to handle that request in time to do that. And so ultimately, scale to 0 is really cool. It is kind of a magic trick because, yeah, if your solution is off, you do need that reverse proxy to be able to wake it up. So why do we autoscale? We autoscale because we want to reach capacity when we can and pay less when we don't need to. And so that is a lot of fun, being able to show you horizontal pod autoscaling. You can grab these slides right now at robrich.org and find me for the other questions on Twitter and Mastodon. Thanks.